We're going to do at least 1 and 3 together, maybe 2, depending on how I feel. Alright, we'll do purple so you guys can have flashbacks to Mr. Peters' class. Alright. Number 1. A ball is thrown up with an initial velocity of 20 meters per second from a 13-meter high cliff. How long does it take the ball to hit the ground? Sometimes it helps to draw a picture here. I'm going to draw a picture on these. So a cliff is 13 meters high. The ball goes up, comes straight back down to there. Okay. What do we know in this problem? Okay.
The height of the cliff.
Right, the cliff is 13 meters. What can we put that in as? James?
Delta y equals negative 13 meters.
Delta y equals negative 13. Everybody understand why that is? We're 13 meters lower than when we started. Anything down is going to be negative. Alright, what else do we know?
The gravity. So the acceleration, negative 9.8 meters per second.
Yep. And what else do we know?
Initial velocity.
Initial velocity. 20 meters per second, right? Okay. And what are we looking for? Time. Alright. Do we have an equation that incorporates all of those? Yes, we have delta y equals VOT plus 1/2 GT squared. So we get 20 equals, oh no, not 20, negative 13 equals 20 t plus 1/2 times 9.8 times t squared. What happened here?
Quadratic.
We can quadratic this. We don't have to. We can, well, does anybody have a quadratic in their calculator? Let's do it real quick just for kicks. I'll show you the other way to do it. So we got 0 equals, that should be negative, sorry. Negative 4.9 t squared plus 20 t plus 13. Never do the quadratic formula by hand because you will not get it right. Just gonna be honest with you. I've seen, like, in my time here, probably like 30 times people have done the quadratic formula by hand. None of them have ever done it right. They've gotten the actual problem correct. So, use the quadratic formula on your calculator. If you don't have it on your calculator, Google it and figure out how to program it onto your calculator.
Oh, isn't quadratic spelled with a T?
Alright, so this is actually Neil flying off the stage.
So we're doing a Neil instead of initial velocity. 20 meters per second.
Alright.
Yeah, you do.
So does anybody actually use the quadratic formula on their calculator to find the time yet?
I don't think anyone.
4.65.
1.65? You should have gotten 2 answers. What was the other one?
4.65 and negative 0.57.
Alright, so you will get 2 answers. Which of those is correct? The negative one, yeah. The 4.65 is correct. What's kind of interesting though is the negative answer you get is if we launched Neil from like ground level up to there, it would have taken 0.57 seconds to get to that height. So that if you actually like went backwards in time from here, it would take 5 seconds to get down to there. Does that kind of make sense? It's kind of interesting. All right, I'm going to show you another way to do it. If you do not want to use a quadratic formula on this, we can just use two equations. You can also do it piece by piece. You can figure out how long it takes to get to the top, how high it goes to get to the top, and then add that to 13 and figure out how long it takes to fall that far, but that is needlessly complicated to do it piece by piece. You can do it that way if you want to try it. I'm not going to do it that way today. Quadratic formula is probably the easiest way. Other way is we can find final velocity first using this equation. Vf squared equals Vo squared plus 2g delta y. So we get Vf squared equals 20 squared plus 2 is negative 9.8 times negative 13. Somebody do this math for me. I intentionally did that.
He's saying something.
It's not always
Correct spelling now. Alright, so what's Vf squared equal here?
654.8.
Alright, what does Vf equal?
25.6.
What needs to be in front of that since we took the square root? Plus or minus. Is it moving down, or is Neil moving down or up at the end before he gets impaled by the spikes and eaten by the dragon?
Down.
Down. So is it positive or negative 25.6? Negative. Alright, so that's our final velocity. Now we can just use one of the other equations to find our time, because we have final velocity, so we're going to just use Vf equals Vo plus GT. So we get negative 25.6 equals 20 plus negative 9.8 times t, and we get negative 45.6 equals negative 9.8 t, and what does t equal? About 4.6 or so, 4.7, yeah.
Does that take into account the time it would take for the ball to be thrown up?
Yes.
And that it does?
This does take into account the time it takes to be thrown up.
Oh.
We're taking that into account because if you look at this, this is positive, this is negative, so this is going up, and this is going down.
Yeah.
So we have both of those taken into account. Does that make sense? Alright, so what's our time? Should be 4.65 probably. Is that what you get when you take... You guys aren't listening to me, so I'm just going to write it down. Alright, so there are two ways to do that problem. Does that make sense, everybody? Any questions about that? Right. But you're probably going to have the quadratic formula programmed into your calculators, because on some other problems we'll actually need it, as opposed to just having the option to use it. Alright. Actually, let's do Let's do number 3. A rock is dropped from a steep cliff, and the sound of it striking the ocean is heard 4.25 seconds later. The speed of sound is 340 meters per second. How high is the cliff? Alright, let's draw a picture. So Neil is dropped from the cliff. We'll assume he's unconscious, otherwise the scream would get in the way of hearing the splash. So he falls in the ocean, and 4.5 seconds later, the sound of him hitting the ocean goes back. And we're looking for the height. Alright, so we have 2 parts here. We have Neil falling and the speed of sound coming back up. Does that make sense, everybody? Alright, what do we know about Neil falling?
9 point.
G, 9.8 meters per second squared. The speed of sound coming back up, just so you guys know, it's going to be constant velocity, so we're just using v equals delta x over t for that. So when the sound comes back up, it travels at a constant 340 meters per second. Does that make sense? Alright, what else do we know about Neil falling?
The initial velocity is 0 meters per second.
Initial velocity is 0 meters per second. Do we know anything else about Neil falling? Nope.
He deserved it.
I'll write that on the board. Alright. I should remember I'm on video now. Alright. What do we know about the speed of sound coming back up? Yep, so the velocity is 340 meters per second. Do we know anything else? Okay. Can we make any progress with either of those? Nope. Alright, I'm going to call, we kind of know something about time, I'm going to call this T1 equals something, and that T2 equals something. What do those 2 times add up to? Yep. So we have T1 plus T2 equals 4.52 seconds. Does that make sense, everybody? What do we know about the 2 distances? They're equal and opposite. So we have, I'm going to call this delta x1, this delta x2. So we also have delta x1 equals negative, and make this one delta x2. Does that make sense? Okay. So now, we're kind of stuck, aren't we? What we're going to have to do is use these 2 things and substitute into them to see what we can figure out. Because if we can get any of those variables, we've got the answer. If we can get T1 or T2, we can get the answer from there. Alright, now because I know where this is going, we're going to start with that one. Let's start with
Way to go, Emily, in our class.
He just
okay. One year I had a kid hiding in there for like I think it was Halloween with a giant clown, those scary clown masks. He got here really early and hid in there, and then like 5 minutes into class, he just sort of slowly opened the door.
It was.
It was Eddie Grohl. He graduated 2 years ago, I think. All right. So we're gonna start with this one. What can we, for this part, what equation can we put in that has G and VO that equals delta X? We also like it to have time involved, so we have this relationship for time.
The third one, I guess.
So we're going to use the equation we're going to use here is we're going to put in delta x1 equals VOT plus 1/2 GT squared is going to go in there. And this one we can use, since V just equals delta x over t, we can use delta x2 equals V times, those are going to be T1s for this side. So that can go in there. Does that make sense what I'm going to do when I write that down? Alright, so we end up with this whole thing in parentheses. Negative VOT plus 1/2 GT squared equals V times T2. Everybody with me so far? I'm going to start plugging stuff into this now. I'm going to distribute that negative, so we get negative 0 times T1 plus minus 1/2 negative 9.8 times T1 squared equals 340 times T2. Everybody still with me? Okay, I'm going to simplify this out a little bit, just get rid of some things, so we end up with 4.9 T1 squared equals 340 times T2. So, we still have a problem. We have one equation, two unknowns. What do you think we're going to have to do? Yep, so we're going to solve this. We're going to say T2 equals 4.52 minus T1 and substitute it in. Why am I solving for T2 and not for T1? Because T1 squared will make our lives miserable. I don't want to FOIL that out. So we're going to do 4.9 times T1 quantity squared equals 340 times 4.52 minus T1. And now we have one equation and one unknown. So let's do some math. 0 equals negative 4.9 T1 squared plus, minus 340 times T1 plus, 340 times 4.252. Alright, so what do we have to do? Dragons. Can somebody within that calculator tell me what T1 equals? Just Google how to program it into your
I've got
calculator.
a big old fraction.
I got it.
Negative 73.6 or 4.3. Are we just going with one decimal place?
4.3 smash. Alright, which one of those is correct? Negative 73 seconds or 4.3 seconds? Since our total time is 4.5, I'm thinking we can eliminate the 73. It's also negative, which time can't be, so we should be with 4.3 here. So that sounds reasonable. So our time for it to fall is 4.3 seconds. So that's T1 up here, it's 4.3. And this would be 0, 2, 6. There, 2, 2. Okay, so now we're going to use that time to find delta x1 here. So we're going to say delta x1 equals VOT plus 1/2 GT squared. We get 0 plus 1/2, I think of 9.8 times 4.3 quantity squared. And what does that equal? Should be about 80 something, I think. Maybe 70 something.
Negative 90.6.
Maybe 90.6. Alright. Any questions on that one? And we can also check it. Somebody do 0.22 times 340 and see what you get. Should be somewhere very close to that. 0.22. 75? We must have. Did you round up to 4.3?
Yeah. It was 4.26.
Oh. Let's do it again.
Nika, you got that.
This then becomes 0, 2, 6. What'd you get?
88.9 or negative.
And what does that equal?
88.4.
So our height, 88.9 or 88.4 would either be acceptable. I would be, when you keep that time, keep 2 decimal places. Otherwise you get varying different answers.
Anything you're squaring, pretty much.
Anything you're squaring, you want to keep a couple of decimal places.
Yeah, because I got negative 90.6.
Yeah. Like, I would go back and check your work on like a test or something like that.
So 2 meters off would be like too much.
2 meters off would be fine.
Okay.
Like if you found it and then subtracted, 15 would be a problem.
That could be a problem.
Alright, you guys have any questions on this
I mean,
one?
either way you're dying, so.
This water,
Which feels like a brick
80,
wall.
80 meters.
90 meters off.
it's not like a football field. I didn't say it was belly flopping, so you could survive.
It's broken everything.
Alright, any questions about this one? Dude,
Under the line you have, you said it equals VT2, but like to the bottom left it says delta x2 equals VT1.
no,
It's like,
that should be VT2.
oh,
Sorry about that, thank you for pointing that out. Any other questions? How do you guys feel about a problem like this?
Not too bad, I guess.
Not awful?
I don't like it.
Emma, you're making a bad face.
It's just my face.
Alright,
Nobody cares.
I'm gonna have you guys try the rest of these kind of on your own, see how you do. You are gonna have a group quiz tomorrow, which is open note, and it'll be 15 questions long and graded out of 50 points, so the worst you can possibly do is 35 out of 50. It is, like, you get open notes in groups, so this should help your grade overall. That's the point of group quizzes, to improve your grades.
How big's the group?
Like the 4 people you're around, and we'll shuffle people if necessary.
Buckley and Daniel, did you guys go with that?
They just turned on us.
Okay, go. You're